Hi everyone, welcome to Data Driven. This will be an interesting project that we're going to be working on today. So we will be bringing data science and data engineering together. So we'll see how data engineering actually complement data science. Okay, so just to give you an overview of what is it that we want to achieve is that we want to actually understand the housing market in South Africa, right? So we want to collect the data over the internet on a daily basis. So we just want to see which house is a good deal. So I thought this will be an interesting project to work on and show you guys actually how data engineering and data science work together. Okay, so I'll be working on like very cool technologies and you guys are gonna learn a lot. So we're gonna work with Airflow, we're gonna work with AWS, we're gonna work with Postgres, we're gonna work with Databricks. There's so many components that we're gonna touch on. Okay, so please watch the video up to the end, and there's gonna be a bonus at the end. Okay, guys. So how will we then go about this? So the first thing that I want to show you before we get into the code and the nitty gritty stuff is that I want to show you how this thing works. Like, what's the end goal? What is it that we'll get after building this project? Okay, so we're gonna go into this database that we have, and this database here. So there's multiple tables inside here. So there's a table called full houses, and there's a table for predictions. So for example, we can take a look at the second house that we predicted that this house is 4.3 million and the actual price was 2.2 million, right? So we can actually take this housing number and we can see if this house is still in the market, because for me this is a good deal, right? So my model says this house is worth this much and this is the actual price. Then in my mind, like, this is the good deal, right? So we're gonna take a look and we're gonna search and see if we can get this house. Okay, so I'm just gonna search for this house. Perfect. So we're gonna copy this link and we're gonna go to our to the web and we're gonna try to see this house. So look at this house is no longer there. It makes sense because it was a good deal, so someone grabbed it very fast. So totally makes sense, right? So let's look at another example. So we can see that this house here, it was 6.5 million, and the actual the model predicted that this house will be 4.2, right? So these predictions are made by machine learning, and we're gonna show you guys how everything works. For now, I'm just showing you how great this is. So we can actually copy this and find the houses. So you can imagine now you're having a real world project. So you can actually upload these links on MongoDB so that it's easy for you to search. So really, it's up to you how you can like store the links so that it's easy for you to retrieve the houses. So look at this house. It's 6 million, but when we collected the data, it was 6.5. So it shows how easy it is for you to kind of like lose money in the housing market if you don't understand the market. So it's very important that you kind of like have something that analyze the data for you. For in this case, it's machine learning. So we can see also that it's easy for you to lose the money because we can see that houses that tend to stay more in the market, they tend to decrease in terms of price. Okay, so you will get all of this information as we go along and you will see how we are able to do this. Okay, guys, so this is awesome. So we'll look at other examples and yeah, so let's get into it. So let's do our simple design and let's see how we're gonna go about this, right? So the first thing that we're gonna have to do is to start with our data engineering, and let's start like designing this and think of like a way in which we're gonna go about this, right, guys? So the first thing that we know is that our source is definitely unstructured data. So we're working with unstructured data here. So we're gonna have to write a script that collects the data for us. Okay, so for example, this will be an extraction system that we have internal that we have built, you know. So we need to dockerize this tool that we have here. The reason being is that obviously you can think of it as we want to scale our extraction system, right? So you can think of this now because I'm in South Africa. So you can think of this part here. We just want to collect houses in Johannesburg, for example, right? We want to collect houses in Cape Town, for example. Okay, so now if we dockerize this, then we can scale our extraction system. Okay, so we can orchestrate this with probably Kubernetes or anything like that. But essentially, this is how we're gonna go with this. Okay, so the second phase is that now we kind of like have an idea of like we're working with unstructured data. So obviously we might want to store this in some sort of like a data lake, right? So we can think of S3 here. We can put S3 here, and we can store all of these houses that we're extracting on the daily basis inside here. Okay, so as a data engineer, you might say, yeah, but what kind of a file do you want to use whenever you're pushing the data into S3? So there's quite different files that you can use, like file type, I mean to say. So there's CSV, there's Packet. So I'll say like Packet is a binary file, right? So what happens is that it's very good whenever you're working with large data. It's very fast whenever you're working with big data. So one of the reason is that it stores data in a more of a column fashion. So it's not row wise, meaning that if you have a data set of like 2 million rows, then you can understand that CSV will try to store this in a row fashion, right? So whereas Packet store this data in a column fashion. So that means the data are kind of like stored in a column fashion if like it is 10 column or 11 columns. Okay, so that's the main difference. So for me personally, I'll say because of we will be collecting daily data, so I want to use a CSV because I don't have a lot of rows. So I'm collecting less than 40 houses a day from a specific location. So it's fine to kind of like use that CSV to store it into S3. Okay, guys, cool. Let's move on. Then, because if we're working with unstructured data, you can imagine that our data does not have primary keys and foreign keys. Okay, so but I wanna kind of like make my data rich. So I wanna bring geographic data in there. So I wanna convert those addresses into latitude and longitude. So to do those transformation, you can imagine now that I'm gonna need a processing layer. Although this is still an ELT, whereby we might want to transform the data into the data warehouse, but I'm just gonna squish data breaks there, mainly because I just want to do these small transformation, right? So you can imagine whereby I want to join my data with geographic data like population and area. So we're gonna have to use an algorithm to do that for us. Okay, guys. So cool. So everything will be orchestrated with Airflow. Okay, so because we want to have an automated system. Okay, guys. So before we move on to the data warehouse and other components, I want to say that we're not working with daily houses only. So sometimes you can imagine that we want big data, whereby we have to kind of like collect big data, let's say in a specific location. So we have to create DAGs in Airflow to collect that data, to orchestrate that pipeline of collecting big data. So for example, let's say I want to collect 50,000 houses in like specific location. So we're going to have to create that. So that's why now here we have to kind of like create two pipelines. Okay. Then we're going to use a format like Packet. So then we might actually want to put the data into a data warehouse, but we have two options inside here. It's not necessarily two options, but here usually what data engineers tend to do is that they tend to use big big data warehouses like BigQuery, like Snowflake, like Redshift, right? Because these databases are columnar, so they're very fast. Whenever you're a data analyst, they're gonna query the data. They can query massive. They can query a lot of data inside here. It's not gonna be a problem. So if you're using something like Postgres, then this will probably go in a transactional situation whereby you're storing your data, it's coming like this, then it's going to be okay. But in this case, what you want to do is that you want to use this type of databases like BigQuery, right? So that's when you can actually start your bronze, your silver, your gold databases, like whereby you kind of like clean the data as you go along and until it's refined, something that Power BI can use. Okay, so that's something also that you should take into consideration. Okay, guys, so this is our data engineering pipeline. Very simple, straightforward. And when we come back, we're gonna look at our MLOps, and I'm just gonna include partially there because it's not everything. And yeah, let's go and start with our data engineering pipeline there. Okay, cool. We in Airflow. This is our Airflow, guys. So we have this. We have our decks in here. So just to give you an overview, like I said, so we have an extraction system. You can think of this. We build it internally. Then what happened is that we then use that system to kind of like extract the data from the internet for us. Then we kind of like store that data into S3, right? Then Airflow will then pull Databricks to fetch that file that was stored in S3. Then Databricks will do the transformation, then throw the data into the data warehouse. Okay, guys, cool. So this is our decks, and these are our tasks. So the first thing that we do is to pull that function that we wrote, like I told you about. Like I said, in a real world situation, you want to dockerize this component because so that you can scale it. So you're not collecting only one you're not only focusing on one location, right? You can like scale that extraction system. But this is the code we're using Selenium. I'm not gonna go line by line because that's not the goal of this tutorial whereby I teach Python or anything like that. My goal is to kind of like show you how data engineering and data science work together. So if you can learn that, I think that will be cool. That's the purpose. But essentially, this is the code that we have. It extracts the data. We're using Selenium, beautiful soup, to scrape the data for us. Okay, guys. Then what we do here, I'll remove all of the secret. So just make sure that you use your AWS secret and password here. So I'll remove them after the tutorial. So yeah, that's okay. So after then, what we want to do is that we create another task to say, after we have pulled the data, just take that data from as a pandas data frame and just upload it into S3. Okay, then that's code here. It will do that for us, right? Then it will then use the file name to tell Databricks that, okay, this is the file name that we just stored. Then start your transformation. Then Databricks will run the transformation. So we're calling Databricks API to kind of like do that for us. Okay, guys, so we're calling Databricks API to do those transformation for us. Okay, cool. So I just want to show you an example of how everything works so that you can kind of like have an idea of what's going on. So now we're gonna go to our Airflow and we're gonna try to run this, and you'll see how everything flows. Cool, let's jump into our Airflow. So let's trigger our Airflow and see what's going to happen. So let's remind ourselves of what's going to happen here. So firstly, we're using our extraction tool to extract the code, to extract all the houses. Then we store that data into S3. Then we're gonna tell Databricks that now you can start the transformation for us. So I'm just gonna take a look at the logs here. Okay, we've started our transformation, and just take the logs. Perfect. So you can see that we kind of like collecting this house here. This is the house that we're focusing on. So these are recent houses. So I'm just gonna load. So I put a break statement there so that we can only collect the first house. Okay, so you can imagine if like I didn't put the break statement, like I said, on a daily basis we collecting less than 50 houses. So you wouldn't wanna, this is a tutorial, so I just wanna collect only one so that I show you the flow, guys. Okay, and this thing, by the way, it's automated, so it's run on a daily basis, so we don't do this stuff manually. So as you can see, I managed to get all the information about the house. Okay, so now that means our second pipeline was triggered. So let's go to that. You see this one here is going to upload to S3 and it's going to call Databricks. So as you can see, we managed to get the job ID. That means the data has been triggered. So we can now go to S3 and we can actually look at the services S3. Okay, so this is AWS, and what you want to do is that you want to go to S3 and see if like it managed to load that file. So it loaded as a S3 packet. Okay, guys, so let's log into there. So by the way, the Databricks API was triggered, so we're gonna see Databricks in a second. Okay, we are now on S3, guys, so let's try to understand what's going on here. Okay, so essentially we have our buckets, and these buckets, they kind of like store all the houses that we collect on a daily, depending on the location that we, or if it's a big data. So we can now see the houses that we just ingested. So we're gonna go under cells, and there is it here. Perfect, sweet. So we have that house. That means now Databricks will know where to fetch this house. But this thing happened automatically. So Databricks, after we loaded the file, then Databricks will start running. Okay, so let's go to Databricks and see our workflow. So under workflow, we have an API that we called, and this API is under we call it daily houses transformation. So it gets called, so now it was called after we just ran that API. Okay, it's very fast, so we can see that it was successful. But now I just want to show you what was going on when this thing was running. So what kind of transformation did we actually do? Okay, so let's go under our data engineering and let's go under daily houses. Perfect. So now we are here. So we are inputting our libraries, and we're getting the file that we loaded into S3. We're pushing it here. Then we're getting all the data that we want to transform for the daily house. And then I told you that I have collected another data that I stored into S3. So this data is all about the geographic data, like population and area in the location that I'm collecting the daily houses for, right? So that I can be consistent. Then I'm resetting all my indexes, and just to give you a glance of how the data looks like, and this is how it looks like actually. So, and let's check. Okay, cool. So this is how the data looks like, and let's scroll down. So here, what we want to do then is that we want to actually convert the data types, and this code here converts all the data types for us. Okay, so I'm not gonna go into too much details of pandas. My goal here is to teach data engineering end to end and machine learning and how they work together. So if you can understand that part, I think I'll be glad then. So cool, let's look at this part. So here I'm just transforming my address because I want to join my address. I want to join my geographic data based on address, so I want to make it consistent. But because of we don't have primary keys and foreign keys, then we're gonna have to use an algorithm that is called fuzzy. So we're gonna do what is called token sort ratio. Then we're gonna join on the address. So if the addresses are more similar, then we're gonna join on that. And this is what it must be look like. So we can see the location is this, and this was the address. So it was able to detect that. That is pretty impressive, right? So with this code here, we're able to do that. What I'm doing now is to say, let's convert our address into latitude and longitude. So I'm just doing that right here, just to convert the addresses into latitude and longitude, because you might imagine now we want to build maps and see all the houses, okay, in a map. And yeah, that's what we're doing there. Cool. And now we're just loading the data into our database because we're done with our transformation. Okay, so the data should be there. If now we go to our database and we try to read in from a table called full house data, and we should be able to see our data inside there. So I'm just gonna say select all from this, and let's run this. Sweet. So now we have our data in there. So as you can see, we have all our houses in there. So many of them. And yeah, so our data engineering should be done. I know that I said you shouldn't use Postgres for your data warehouse, but because here the goal is to teach and show people how everything works, so I think it's just fine. Okay, but yeah, there's our data inside here, and we have all the houses. So let's go and start with our MLOps and see how it works. Cool, let's start with our MLOps. So now we have our data in our database. It can be used by our analyst, Power BI. It obviously still need to be refined, and they still need to go from bronze, silver, and gold tables. Okay, so we're not gonna focus on that, but you can imagine that's something that can be done in the real world project. Okay, guys. So first thing we know is that data scientists, they tend to use unstructured data as in a raw format, like from a raw format that is not being transformed by data engineers or or or, or that is in the data warehouse, and it's been kind of like transformed or something like that, right? So they want it in a granular format. So they might want to go to different databases, and they might want to see where data lies in. So you might imagine that a company has more databases, and the data scientists might actually look at them and see which database has more relevant data to their problem. So in this case, that means that we might actually think of building something like feature store, mainly because we don't want our data scientists to kind of like go through these data sources that we have in the company, and that might be tedious. Okay, so we're gonna have a feature store inside here, and now that means that data scientists will have to read from this, and this will be updated every time data comes in. Okay, so what will be the source? So this will then read from multiple sources. Like I said, it could be S3, it could be Postgres, it could be Excel, it could be anything literally. As long as data scientists can create their own features in here for inference, or online inference or batch prediction, that's okay. Okay, then house market, we know, guys, like it's affected by economic factors. So by economic factors, I mean like your inflation, your repo rate, your your prime rate, and all of these things can actually affect your model. So I'm thinking that then we must have something like data visioning inside here. Okay, guys. So data visioning, just to check the variance of the data if it's still in the same variance. So that's something that we can include, but in this project we're not gonna include data visioning, but just gonna include all of these components so that we know how an end-to-end machine learning pipeline look like. Okay, and then we do know that data scientists like to experiment, right? You can have XGBoost in there, you can just experiment with different things. We don't know what's gonna work and what's not gonna work. We have XGBoost and you have multiple parameters. Then what you want to do in this case is that you want to keep track of these parameters. So we can use MLflow and we can actually store all of these parameters in the repo, all the model in the repository, okay, and package it in a way. So can create another platform here and say package the model. Okay, so by package I mean all the requirements and everything that is required, so that if you're going to deploy the model on Kubernetes cluster, so it's much easier to deploy it because you've packaged all the dependencies around the model. So there is something that we might need, which is Kubeflow. So it's similar to Airflow that we used in data engineering. So it kind of like going to allow us to orchestrate this pipeline for us. I'm not going to touch Kubeflow in this, but probably in the second tutorial, then we can look at Kubeflow. But in this tutorial, I'm not going to touch it at all. Okay, so just but for us to learn, I just need to raise it so that we know that it's an orchestration for machine learning that we can use. Okay, guys. Cool. Now we can actually save our model. I mean, we need our model to be live and we have T saving. So TF saving, you can think of this as now we can deploy our model on Kubernetes cluster and we can Dockerize it. And now if we Dockerize this, then we can then send the traffic to different pods because we can scale that model. So here it's something that you can think of using Kubernetes to deploy a model. So model in production can change, right? Like there's so many things that can go wrong in there. For example, like I said, customer taste changes. And in this case, like we know we're working with houses data and it changes a lot. Like an average price can change very easily. So you might want to put evidently FI. So it's going to allow us to track our model. So it's going to allow us to track our model in production and see if it's still in a good shape. And then you might, if it's losing its accuracy, then you might want to update the model, then go to training your model back again. So okay guys, I think we kind of like have everything that we need. Please note that this is not a complete MLOps, so it might be different from something that you're used to. But for this project, I think this is good. So there's a lot of components that comes in here. So that we might actually not have included, right? So I'll say that machine learning is still relatively something new. So people are trying different things and people have different architectures, okay? So just keep that in mind that at some point you're gonna see different architectures as you go on, right? So yeah. With that said, let's go to our MLOps and see how it works. So yeah, like I said, guys, the first thing that we want to do is to create a feature store, right? So I'm going to use Databricks for all of this. So yeah, we're going to see how everything flows from there. So what we're going to do is that here I'm just taking my data from Postgres and I want to throw it into my feature store. I think Databricks feature store is powered by Delta Lake, so that's where it will be. So the first feature that I'm going to create is to create a distance. Because I'm working with house data, then my feature can be like, okay, let's calculate the CBD of something, and let's see how far away these houses are, because we do understand the central is whereby you have all of these it's a city in a way, right? We have more luxurious things in the city, than in a location whereby, you know, it's not a city, right? I don't know if I'm making sense, but the point is to say, if like we kind of like calculate the distance of how far each house is from the central location, then that could help our machine learning make good predictions. Okay, then we're doing the same thing. We say, if like, what is the most expensive location? If we calculate the distance of how far some of these houses are from the distance location, then that could also be predictive. Then one thing we do is that we do our feature selection, right? um that's the thing here. We just creating our feature store so that we can store our features in there. Okay, then we write them into this table. And this notebook here, it's automated all the time, so whenever there is new data that comes in, so this helps data scientists to have updated features all the time. So now let's go to our machine learning pipelines, whereby we're gonna start training our model. Okay, so cool. Like I said, now because we're training our model, so we're just gonna pull the data from our feature store. So that's what we're gonna start doing, and we're gonna start now doing those pre-processing of the data, because you do understand that we're working with unstructured data that is coming from the internet. So what we want to do then is to remove outliers that might actually affect your model. So this is the data that this is how the data looks like. Then now we start doing some of the pre-processing of the data. You know, like, you do understand that some of our target might be right skewed, so we just want to log the target, and we just gonna try to normalize all the features that we have inside there. Like I said, guys, I'm not gonna walk you through every line by line. So if you guys request me to kind of like create a data science tutorial whereby I teach you about data science, then just leave a comment in the below. Then I'll kind of like walk you through data science lifecycle. And yeah, so it's simple code. Here we just try saying simple impute, whereby we don't have values, just impute those columns. Cool, but only for numerical column, only for columns which are numeric. Then now we're handling those skewed features. So because you do understand that skewed features might affect our model, then we just applying the log to cater for that. Then the last pre-processing step is just to do a dummy processing, so that this is how our final data should look like when it's going into the machine learning training step. Okay, cool. Let's continue. So I'm just gonna remove the primary key there, and we're just gonna split our data, and we're just gonna start training our model with XGBoost. But the most important thing for MLOps, because that's the purpose and that's what we're learning, is that we want to log all the parameters that we're using, and we want to save the accuracy, and we want to save the actual model into the repository. Okay, guys, so that's the main important thing. And yeah, then when we're done, we try 2 different models and see which one get us a good accuracy. And that's it. We're done with our training part. We locked the model and we got a good accuracy. Then now let's go and see how we do batch predictions. Cool. So we're gonna start doing our batch predictions. So we're gonna get the data from our feature store. Then we want to start doing all the pre-processing steps that we did in our training environment. So we're gonna do the same pre-processing steps. Then after we're gonna just make predictions just like that. So this is the model. Because it's been logged, it's been saved on Databricks, then we're just gonna pull the model and we're gonna make predictions and load the data into the data warehouse. But before, I just want to show you what's actually going on in terms of when I'm saying we're logging the predictions and all those kind of things. Okay, so we have a tab here called experiments. So experiments keep track of our model and the accuracy, and we can actually choose which model we want to make it. We want to make it our main models to make predictions. Okay, so this is the tab that you see here, and you can see that 4 days ago we made this model to be the main model to make our predictions for us, to make the predictions for us. Okay, so I'm just gonna show you guys. So perfect. So if now you go to models, I'm just gonna go to models, and you will see which model is actually live. So I've promoted a second model, which is Vision 2. So this is the model that we're using to kind of like make our batch production. So you can actually productionize this model on Databricks, but like I said, usually what I do is that for me personally, I just like take download the model parameters uh, and all the files that Databricks generated for me, and I can actually deploy this model on Kubernetes cluster. So let me show you what I mean by that. So if you go to your experiments and you go here and you select any model, honestly, it could be this. So you will see that we have all of this information. You have your model, your requirements, and everything is literally there. So you can use that to, so your model is packaged. So you can use that now to deploy to deploy your model to Kubernetes cluster and Dockerize this. And now you can scale your model if you want to. Okay, so yeah. With that said, guys, so we can now try to understand the housing market, but this is something that I'm still working on. So I think I'll make a different video to share with you guys how I'm now getting into just trying to understand where the demand is, and so that if someone wants to buy a house, they can really make a good decision. Okay, so I think I'll make a separate video where I'm showing you all of this and how I'm doing my analysis, and I hope you guys gonna join me again, and this will be an interesting part of and we're gonna see how which houses, where there's demand, and yeah, all of that information. And yeah, I think that's all, guys. Thank you very much for tuning in, and I will see you in another video. Thank you. Cheers.